Despite access to over 24 FDA-approved antiviral compounds, more than 1 million Americans have been diagnosed with HIV. Even more startlingly, only 42% of them are actually receiving antiviral treatment. And that's really a bewildering statistic because we know that HIV is still a big problem in sub-Saharan Africa. But here at home, less than half of people that know they have the virus are actually on treatment. And we know that if you have HIV and you don't treat it, it'll progress to AIDS and you'll eventually die. So we have to ask, why would anyone make that decision not to take their treatment? And the answer might surprise you. It's not really their choice. There's two major problems with our current antiviral treatments. And if anything, it's really three major problems. And that's the fact you have to take 3 drugs to successfully abrogate the virus, each one targeting a different mechanism of action. Now, as a result, this is fiscally very expensive, costing over $2,000 a month pre-insurance, which, to put that into perspective, is more than us graduate students even make. And secondly, that has some serious implications for side effects, drug-drug interactions and the whatnot, because you're going to take these drugs for the rest of your life. So even a pretty minor issue can significantly detriment your quality of life. So in the Leota lab, we took a step back and said, if HIV can have all these different complex mechanistics of action, why can't we as humans design a drug that'll stop them all by itself? And that's exactly what we set out to do. Compound 5-103, my lead compound that I've been developing for over 2 years here at Emory University, has all 3 mechanisms of action as the FDA-approved compounds on the left. Like AMD 3100, it stops X4 binding. Like Maraviroc, it stops R5 binding, and like AZT, it stops reverse transcriptase from working. And the way that we've done that is that we designed it through computational screening, which took a lot of the manpower that we lack here at Emory University as compared to Pfizer out of the equation. So we intelligently designed the molecule against our targets and successfully made a molecule that bound to X4 and R5 as well as RT. And over the course of making over 50 chemical modifications where I moved the chlorine around, moved the nitrogen, replaced an oxygen, I managed to increase the potency from my initial starting point by 100-fold. But truth in advertising here, even though I have equal mechanisms of action as a drug cocktail, I'm still 100-fold potency away from being ready to help humans. But what I'm really excited about from this research is that it might help cause a paradigm shift. And instead of people in the future taking a 3-drug cocktail against HIV, this huge horse pill, maybe they'll just take a single drug, and it'll be cheaper and fewer side effects. Thank you.